Hi guys, welcome back to Math 1. This is super weird talking to an empty classroom right now, but this is the best I have to offer. Just encourage you guys to go to Google Classroom, follow directions on our assignments, make sure you're following the proper procedure for submitting the homework, and make sure you guys are social distancing, practicing hand washing, not putting yourself in risky situations to contract any kind of germs from other people. I think I have about 15 minutes to get this first lesson out of the way, so I'm going to try to go through it as best I can. So, here we go. The two goals we have for this lesson are both pre-algebra skills, so that's good news for you guys. The first one is be able to write monomials. Yeah, we talked about that last chapter. As products of prime factors. Product meaning multiplication, prime factors meaning factors that only divide itself and 1. So I'm just going to jump right into the examples. Our first example is literally the monomial 60. So what we're doing with 60 is we're basically just saying, what are all the prime numbers that make up 60 when we multiply them together? So a factor tree is a good way of visualizing this. Factor trees are usually good for cutting them in half first because 2 is a prime number. So I've got my first prime number. It's 2 times 30. 30 is also even, so I'm going to break that down by 2. 2 times 15. 15 is not divisible by 2, so I'm going to take the next prime number, which is 3, try it out, and it works. Now, when you get to a prime number on the right-hand side of this factor tree, you know you're done. So 2 times 2 times 3 times 5 is technically the prime factorization for 60. Now, I'm going to ask you guys to put a 1 out here in front every single time. You'll see why in the next lesson. Because 1 is a prime number. But again, next lesson. All right, what happens if there's variables involved and a negative? Well, all we're going to do is just kind of like circle these and pretend they're not there. So think about 112. 112 is divisible by 2. Half of it's 56. Feel free to use a calculator, by the way, to make the burden of computation less. Cut 56 in half, that's 28. We get another even number, cut that in half. You get 14. Got another even number, cut that in half, and you get 7. 7's a prime number. So we know that 112 has a prime factorization of 2 times 2 times 2 times 2 times 7. We're going to remember to put a 1 out front here. Now we take care of the negative and the variable expression that attaches with it. So if it's negative, just multiply the whole thing times negative 1. And if it's m to the 4, that just means we're taking m times itself 4 times, n to the 3, n times itself 3 times, and then 1p. There it is. So that's the way I want you guys to do the prime factorization for monomials. And there's your final answer. And by the way, the reason why I'm expanding these expressions out and also not putting 2 to the 4th power, you'll see tomorrow, okay? All right, try number 3 and 4 on your own. So pause the video. Unpause. Here are the answers to number 3 and 4. $143 is kind of a tricky one. If you take your calculator and take 143 divided by all the numbers leading up to 11, you'll find that 143 is 11 times 13. Now both 11 and 13 are prime numbers, so you basically have the prime factorization already. 143 is 1 times 11 times 13, and that's a perfectly legit way of multiplying that out. 310 has some more. So you can cut 310 in half. That's 155. 155 does not divide 3, but it does divide 5. and that's multiplied by 31. So 31 is a prime number, 5 and 2 are prime numbers, so negative 310 is equal to negative 1 times 1 times your other primes. All right, so that's our first goal. Be able to rewrite monomials as products of prime factors. Not too bad. Now, what is this business of pairs of factors for integers? Well, if you'll recall, an integer is a positive or negative whole number. So these two are technically integers in and of themselves. So sets of factors, or really they should be called pairs of factors, are basically just me asking, what two numbers could I multiply together to get negative 72? And what two numbers could I multiply together to get 240? And there should be a pretty extensive list for each of them. It's not just a one and done answer. So when we think about this, every single number is divisible by itself and 1. So right off the bat, negative 72 can be written as negative 1 times 72. But we could also multiply, since it's an even number, negative 2 times something to get negative 72. It's 36. And then you just roll down the numbers as you increase. So does negative 3 divide 72? It does. Does negative 4 divide 72? It does. 5 doesn't because it ends in a 2. 6 does. It ends up being 12. 7 does not. 8 does. And then once you find that you're pretty close to each other, 8 and 9 are side by side, you're done. Now, there's something interesting you have to take into consideration here. To get a negative number, you need a negative times a positive. Well, what happens if I were to reverse these and say we had a positive 1 times a negative 72? Well, that technically is a distinct pair of factors from negative 1 and 72. So I have to take that into account for all of these. So positive 2 and negative 36, positive 3 and negative 24, positive 4 and negative 18, positive 6 and negative 12, positive 8 and negative 9. So those technically represent my full list of the pairs of factors that make up the integer negative 72. And I'm just talking about integer factors. I'm not talking about like 1/2 times 144. I'm just talking about positive or negative whole numbers that will get you to negative 72 when you multiply them. By the way, if you're wondering like what the heck's going on, why are we doing this? This is a skill that is basically preparing you guys for something that's going to happen a little bit later. I just thought it felt like a good lesson to put in here right now as we're stuck at home and we just need some pre-algebra to get us jump started again. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm just going to put that up here for just kind of to note that there's 12 pairs of factors here. It's just always good to keep a running count of that kind of thing. All right, 244. I bet you guys could probably do this one on your own. So if you want to pause the video and try to figure them all out on your own, go ahead and do that now. All right, you've unpaused it. So hopefully you've got 1 and 240. By the way, I think on the homework I put commas in between. Really, I should have put a dot for multiplication. It's kind of like talking about the same thing when you ask for pairs of factors. So I'll just keep it with the dot here. 2 and 120, 3 and 80, 4 and 60, 5 and 48, 6 and 40, doesn't divide 7, 8 and 30. Does it divide 9? Let me double check. I don't think it does. No, it does not. It does divide 10 though, because it ends in a 0. 24 times 10. 11, 12, 20, and then 15, I think 15, 16. Let's double check that. Yippers. Okay, now, hopefully you guys got that. And then you have to take into account that there's going to be a second row or column of factors. Here's why. A positive times a positive yields a positive 240, but so does a negative times a negative. So technically, each one of these has a corresponding negative times negative list. So you can probably like shoot forward in the video. I'm just going to put the rest of these down. Okay, so we've got 2, 4, 6, 8, 10. 10 times 2, there's 20 pairs of factors here. And we'll move on to the last one, number 7. So 323 is kind of a tricky number. It's not even, so we can't start out with the even numbers. And you'll quickly find that with 323, that 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work. And you're kind of asking yourself, like, at what point am I kind of like off the hook for checking this thing? Maybe the thing doesn't have any factors. Maybe it's just 1 in 323 and that's it. Well, we do know that 1 in 323 work for sure. But so does negative 1 and negative 323. The question is, what's a good way to kind of like go to the end and make sure that we're not just needlessly punching numbers in our calculator? And that's where the square root comes in. If I take the square root of 323 and check out the decimal for that, I get 17.97. This means that once I check all the way up to 17, I'm done. Because anything above it would be paired with one below it. To take into consideration that with our previous example, 240, if I took the square root of 240, I get 15.49. Our last factor was 15 times 16. So, if we take the square root of 323 and look at 17.97 as its decimal square root approximation, we can start with 323 divided by 17 and then maybe work our way back to the smaller numbers. Interesting. So 323 divided by 17, just curious if it's going to work out. Yes! 17 times 19. So then the negatives also work. Here's the thing. Because 17 and 19 are both prime numbers, that indicates that nothing between the 17 and the 19 and the 1 and 323 will actually divide 323. So you can try 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, but none of them are going to divide 323 because the two factors that kind of were bookending the square root, 17 and 19, 17.97 was right in between those two. Because they're prime numbers, you got nothing else to do. So, I hope that was helpful for you guys. Please be patient with me. This is my first math video, so I'm going to make mistakes probably. Some things might not be as clear as they could be for a seasoned veteran of this, but the homework for this is just do the odds. The even answers are posted on Google Classroom, and good luck. Please email me directly any questions you may have, and be sure to read the directions on how to post your assignments. All right, see you guys.